You're sitting in the cockpit. The sun is setting behind the horizon, and everything seems perfectly normal until it isn't. You've heard the stories of pilots who just vanished, leaving nothing but a silence on the radio and a search party that eventually gives up. It's the ultimate nightmare for anyone who flies small aircraft. We like to think that with modern GPS, ELTs, and radar, it's impossible to just disappear, but the reality is much darker and more technical than most flight schools will ever tell you. Today, I'm going to break down the real reasons why small planes keep dropping off the map without leaving a single trace behind. I'm not talking about urban legends or Bermuda Triangle nonsense. I'm talking about the cold, hard physics of structural failure, the limitations of our tracking technology, and the psychological traps that lead pilots into the abyss. By the end of this, you'll understand exactly what happens in those final seconds, and why, in many cases, we never find what's left. But here is the detail that nobody tells you. It's almost never just one thing that goes wrong. It's a specific chain of events that makes a plane invisible to the world. Reason number 5 is the complete and instantaneous structural disintegration at high altitude. Most people think that if a plane has a structural failure, it just glides down or leaves a massive debris field. That's not how it works when you're dealing with high cycle fatigue in older airframes like the Piper PA-28 or the Cessna 210. When a wing spar snaps or a horizontal stabilizer fails due to undetected corrosion or stress fractures, the aircraft doesn't just fall, it shreds. If this happens at 10,000 feet, while you're cruising over dense terrain or open water, the pieces are scattered over such a wide area that they become practically invisible to search and rescue. Think about the physics for a second. An aircraft traveling at 140 knots that suddenly loses its structural integrity becomes a cloud of aluminum and composite material. The heavy components like the Lycoming O360 engine block will sink or bury themselves deep into the earth, while the lighter skin panels are carried miles away by high-altitude winds. By the time the alarm is raised, the crash site doesn't exist as a single point. It's a 5-mile radius of scrap metal that looks like nothing from the air. This is especially true in regions with heavy canopy cover like the Amazon or the Pacific Northwest. You can fly a helicopter directly over a downed engine and never see it because it's buried under 3 layers of vegetation. The radar might show a target 1 second and then nothing the next. This isn't a mystery. It's just the result of a machine being pushed past its metallurgical limits until it ceases to be a machine. Moving on to reason number 4, we have to talk about the catastrophic failure of the electrical and emergency signaling systems. We rely on emergency locator transmitters, or ELTs, to tell the world where we are when things go south. But here's the reality. The success rate of older 121.5 MHz ELTs in actual crashes is abysmal, and even the newer 406 MHz units aren't foolproof. If a plane enters a high-speed vertical descent, what we call a graveyard spiral, the G-forces and the impact angle often destroy the ELT antenna before it can even send a single burst. Or worse, the unit is submerged in water or buried under the engine block, which effectively shields the signal. If you're flying over a remote area and your electrical system fries due to a master bus short or a catastrophic alternator failure, you lose your transponder. You become a primary target only, and most civilian radar systems are tuned to filter out primary targets to reduce clutter from birds and weather. You effectively become a ghost in the system minutes before you even hit the ground. Without a transponder and without a functioning ELT, you are just a needle in a haystack the size of a continent. Pilots often forget that these safety systems are fragile. A simple loose wire or battery that's past its prime can be the difference between being rescued in 2 hours or being missing for 20 years. It's a technical vulnerability that we've accepted in general aviation because the cost of truly redundant, satellite-linked tracking is still out of reach for the average owner pilot. Reason number 3 is the phenomenon of in-flight fire and immediate incapacitation. This is perhaps the most terrifying scenario because it leaves the aircraft perfectly capable of flying for hours after the pilot is already dead. If you have an electrical fire behind the instrument panel, often caused by aging insulation on wiring that hasn't been inspected in decades, the cockpit fills with toxic smoke in seconds. We're talking about burning plastics and insulation that release cyanide and carbon monoxide. In a small cockpit, you don't have time to put on a mask or open a window before you lose consciousness. Once the pilot is incapacitated, the aircraft, if it's trimmed correctly, will just keep flying on autopilot or in a stable glide until it runs out of fuel. This is how planes end up hundreds of miles away from their last known position. The search teams are looking near the last radar contact, but the plane is actually 3 states away, resting at the bottom of a lake or in a remote canyon. It's a ghost flight scenario. By the time the fuel runs out and the plane finally crashes, it's so far outside the search grid that nobody will ever think to look there. The wreckage stays hidden because the trajectory was completely unpredictable. This happens more often than you'd think, especially with pilots who ignore that faint smell of burning plastic during pre-flight, thinking it's just the heater warming up. It's a silent killer that erases the evidence of the crash before it even happens. Now, reason number 2 takes us into the realm of extreme weather and microburst-induced terrain burial. When a small plane encounters a severe downdraft or a microburst, especially in mountainous terrain, the forces are so great that the aircraft is literally slammed into the ground at terminal velocity. We aren't talking about a controlled emergency landing. We're talking about a high-energy impact that can actually bury the aircraft. In soft soil, swampy areas, or deep snow, a small plane like a Beechcraft Bonanza hitting the ground at 200 knots can disappear beneath the surface. The Earth literally swallows the machine. Within a few days, the disturbed Earth is covered by new growth or washed away by rain, and the crash site becomes indistinguishable from the surrounding landscape. I've seen cases where search teams walked within 50 feet of a buried aircraft and never saw a thing because there was no fire and no visible debris. The plane is just gone. It's under the mud, under the silt, or under 30 feet of snow that will never melt enough to reveal the metal. This is why the missing status persists for decades. The environment itself acts as a shroud, hiding the technical failure and the human tragedy from the eyes of the world. It's a reminder that nature doesn't just break our machines, it reclaims them. Finally, we reach reason number 1, the most common and yet the most ignored reason for these disappearances: the human factor of intentional deviation and fuel exhaustion over unreachable terrain. This isn't about suicide, it's about get-there-itis. A pilot encounters unexpected headwind or weather, and they decide to take a shortcut over a mountain range or a stretch of water they aren't equipped for. They deviate from their flight plan without telling ATC because they're busy trying to solve the problem. They're focused on the fuel gauges, the changing weather, and the mounting stress. When the engine finally coughs and dies due to fuel starvation, they are 50 miles off their reported course. They try to glide toward a clearing, but in the dark or in the clouds, they end up in a ravine or a dense forest. Because they deviated from their path, the search is conducted in the wrong place. The trace is lost because the pilot themselves erased it by moving away from the safety of the planned route. This is the ultimate trap. You think you're being smart, you think you're handling the emergency, but you're actually making yourself invisible. By the time you realize you're going down, it's too late to broadcast your coordinates. You hit the ground in a place where no one expects you to be, and the forest closes in. It's the combination of a technical limit, the fuel capacity, and a psychological failure that creates the perfect conditions for a permanent disappearance. You see, these planes don't vanish because of magic. They vanish because of a series of technical vulnerabilities and human errors that align in the worst possible way. We fly machines that are often 40 or 50 years old, held together by aluminum rivets and hope, and we push them into environments that are fundamentally hostile to human life. When the wing spar fails, when the ELT breaks, when the smoke fills the cabin, or when the fuel runs dry, the margin for error disappears, and when that margin is gone, the plane often follows. It's a sobering reality that every pilot needs to carry with them every time they pre-flight. The sky is vast, the Earth is unforgiving, and our technology is more fragile than we like to admit. If you want to make sure you're not the next one to disappear, you have to respect the machine, respect the weather, and above all, respect the limits of your own ability to handle the unexpected. Because once you drop off that radar screen, the world becomes a very large and very lonely place.